Hello and welcome to the Energy Resilience Lab. Our lab is dedicated to giving you the knowledge, skills, and encouragement that you need to take control of your energy destiny. We have three formats of show that we provide for you in our lab. The first one is informational, so that's to give you training about different aspects of energy and power and how it works in the real world right now. The next one is interview style. So that's where we'll be interviewing people and bringing them in so they can share knowledge with us about how the utilities work or how different small systems work to get you guys into the nuts and bolts of the system. And then the third is news-based. So that will be bleeding edge news with new developments in the market, as well as things that are going on around us. So we'll be going over news related that pertains to energy and to power so that you can learn what you need to take care of yourself and be able to be energy resilient. Today I'd like to go through the kind of basics of energy, and so we'll just be reading through what the definitions are and the different types, and then go into more practical information on how it works and how it can be utilized for us to have energy storage or for us to have large-scale energy generation. Energy is the quantitative property that is transferred to a body or a physical system, recognizable in the performance of work in the form of heat and light. Energy is the quantitative property that is transferred to a body or to a physical system, recognizable in the performance of work and in the form of heat and light. Energy is a conserved quantity. The law of conservation of energy states that energy can be converted in form, but not created or destroyed. The unit of measurement for energy in the international system of units is the joule. So energy is more simply defined as the potential to do work. So energy can be in the form of electrical energy, and that would be where you have potential in all of the sockets of your home, or maybe in a device if you have an energy storage system. But it's the potential that can be converted to work. So now we should move on to define more what work is and more what the different types of energy are. Common forms of energy include kinetic energy. That's the energy of a moving object, so someone throwing a baseball or something, that would be kinetic energy. Potential energy is energy stored in an object. So if you have an object and it's high up on a mountain, like a large boulder or something, it has potential energy. And if it breaks away from the mountain and falls down, you'll see that potential energy convert to kinetic energy as it accelerates coming down the mountain. Elastic energy is energy stored in a solid object. So that would be when you have a bouncy ball, for example. If you crush the bouncy ball, you're adding energy to that solid object. And then when it responds back through its own release of the strain in the body, that energy can exit that object. Chemical energy would be a form of gasoline or diesel or energy that is in a chemical. So if you have a exothermic reaction, that means when you break down a material, it allows the energy out of the mass of the fluid or solid, and that is converted to heat usually, and then we can utilize that for different things, like in the case of an internal combustion engine. Next, we've got radiant energy. So that's energy carried by electromagnetic radiation. So that would be the energy of the sun, or just in general, every object gives off heat. And so if you've seen images of infrared, you're looking at what the object is actually giving off. And then also there's internal energy contained within a thermodynamic system. So in thermodynamics, we have to simplify our models to be able to understand the world. And so we will take a certain mass or body or region, and we will calculate how much energy is in that region. And since energy is conserved, that means that the energy in that system can't change. So it can't disappear. So it can be converted from different types. So you have electrical energy, you have energy in the form of temperature in the bodies, and so you'll have different conversions, but the amount of energy in the system will stay the same. So in the case of an internal combustion engine, you have chemical energy in the fuel, and that fuel is injected into a mechanical system that burns that fuel and then creates movement from the heat. So you have the air-fuel mixture that enters into the cylinder. It is combusted, causes pressure differential between inside the cylinder and outside of the cylinder. So that causes a torque to be created on the crankshaft, and that is converting the energy from chemical to kinetic. So that is an energy conversion. And with that, we need to start to learn the realities of physics, and the fact is that there are thermal losses that occur in every system. And so the thermal losses mean that some of the energy, like in that chemical system where you're converting chemical fuel to movement, in the case of an engine, or heating things with the thermal losses of the engine, that engine is able to convert that power at a certain efficiency. Usually with internal combustion engines, it's around 16%. There's different things that can help with that. So having a turbo or other systems on the engine can raise the efficiency, but it usually ranges from 16 to 40%. So going from an internal combustion, naturally aspirated, to a diesel engine, just the compression ratio gives you a higher efficiency in that combustion. And what that means is you have a certain amount of energy in the fuel, and when it is put into the engine and used, you get a certain amount of work out. And work can be motion. It's usually motion in that case where you're trying to get a vehicle to move. So we're able to capture 16% of the energy as the engine's running, and after it's converted, or while it's converted, there's a lot of heat that has to leave the engine. So if we weren't able to get the heat out of the engine, it would cause it to overheat. I'm sure everyone has experienced that, where they don't have enough coolant in their cooling system, or they have air-cooled system and it's not getting enough air. The engine will just get too hot. And that's because the thermal losses have to go somewhere. So in solid objects, as they get more heat, their temperature increases. And so that's what you get with an engine excreted from the system in the form of heat. So in cars, car manufacturers make cooling systems to get that heat out of the engine. We use some of it, so it's kind of a combined heat and power system in an automobile. So as the engine's running, you're able to use that heat to heat other systems in the car. The catalytic converter, that helps to clean up the exhaust in the vehicle. You can also use the heat in the occupant area to warm up the vehicle if it's a winter situation. And then in the case of air conditioning, you can use torque off of the engine to convert it in a heat pump to move heat out of the cabin into the atmosphere, causing the cabin temperature to come down to keep it cool for people to be comfortable. So all that to say that there are energy efficiencies. There is a lot of energy in fuel-based systems. In many cases, a lot of the energy is lost to heat, but it can be useful to have heat because we, as humans, like to be warm. So it's nice to have the ability to move and to have a heated cabin where we can relax and stay warm, or cool in the case of air conditioning. But so we have energy, it's converted in an engine. You can use it to do work in the case of an air conditioner, or to move the vehicle, or you can use the heat coming off the engine to heat the cabin in the case of it being cool outside. So this efficiency, though, is true of all systems. So if you have an inverter powered system and a battery, so you have a battery and an inverter, and you're using those to power different systems in your RV home, or just in a power unit while camping, those systems have losses associated with them. So when you're purchasing a system, they'll tell you what the nameplate energy is of the battery. So it might be 500 watt hours, or it might be 1,000 watt hours. And the watt hours that is the energy. So it's the potential to do work. It's not doing work, it's just stored in the battery, but it's there and ready to go when you do need to use it to power a system. So once you go into an inverter or any other device, there's going to be some losses associated with it. Usually most inverters, you're pushing around 90% efficiency. In the case of solar, AC coupled solar, the microinverters are said to be between 98 and 99% efficient. And that's just giving you the ratio of how much energy is lost to heat and how much energy is actually transmitted for use. So in all of these systems, you'll have some losses, and you have to take that into account with energy storage systems. So that's why we're bringing this up today, is so that we all can understand that you can build a system, measure all of the loads that you're going to need, all the things you're going to plug into it to use with in the case of an outage, or when you're camping. But we always need to take into account the efficiency of the system if it's not very close to 100%, so that we don't run out of energy, because that's one of our outputs of energy. So just going through kind of all the types now of energy. There's mechanical, so that would be translational, rotational, or essentially energy in relation to movement. So one of the functions of a mechanical energy storage system, or one of the types of energy storage system that uses mechanical, would be a flywheel-based system. So a flywheel-based system has a mass that is accelerated. So you give it angular momentum by adding energy to it. You can add energy to it you could add it from solar, you could add it from the grid, however you want to add the energy. Common use for these systems would be in data centers. So data centers usually need UPS power, and a lot of them have flywheel energy storage systems just to give them enough time to shut down the system in the event of a power outage. So that's a mechanical energy storage system. Electrical energy storage is essentially potential energy that is stored in electric fields. In the case of a transformer, when you have a transformer active, there is some potential energy in the transformer just due to the electrical function and the electrical requirements of the transformer. So if you have a transformer energized, it does have potential. It's like in electrical systems, just having capacitance and inductance means that there is some energy stored in it. It's not that useful for us just because we need a lot of energy, but there is some energy in there that can give some instantaneous current on the output, or that can slow us down and impede us if we're trying to induce current into it. So there is some energy backlash essentially involved with transformers, so that would be a form of electrical energy. There's magnetic energy, so this would be in the case of actual magnets. So just magnets are able to do some work, so they can lift metal objects to themselves just by the energy of the magnet. And they're used heavily in motors and other systems as functional elements. Gravitational energy is another one, so that's where we can store energy in a fluid or in a mass that is elevated. The easiest one here in the western United States would be to see large reservoirs. So when we have a lot of water stored up high, that is gravitational energy. So the gravity is acting on it And so every foot of water that you have above an outlet gives you 0.4 psi of pressure. And so that can be used, that gravitational force on the liquid can be used to store energy and then to bring that energy out or to export that energy through a turbine and converting it to electrical energy or some other form that you need in that area. There's ionization energy, and that's potential energy that binds an electron to an atom or a molecule. And then there's nuclear energy, so that's the potential energy that binds nucleons in the form of the atomic nucleus. So nuclear energy is the energy of the nucleus being held together. So when we are doing fission, you're breaking that apart, and then the energy that's released when that comes apart is what you're utilizing to have nuclear energy. Chromodynamic energy is one that I haven't really heard of, but it is potential energy that binds quarks to form hadrons, components of an atom. Elastic energy, like we talked about, is the energy within kind of the strain of a body. So you can think of a bouncy ball and crushing it, you add energy, letting it go allows that energy out. So when you bounce it, it crushes and then it gives back that energy. So that is called the restorative force when it goes to its original shape and lets that energy out. Mechanical wave is kinetic and potential energy in an elastic material due to propagation, oscillation of matter. So mechanical wave would be in a body, so when sound touches metal or some other material, stone, anything, the sound will go through it in the form of a wave, and that is kinetic and potential energy as well, building up and exhausting through the fluid, through the material. Sound waves have energy, and then we've got radiant, so that would be light, like the sun, like we talked about. And then thermal energy would be energy just in a body that gives it its temperature, or what we measure as temperature. So these are all the different forms of energy, and we've talked about different ones that can be utilized in energy storage systems. Usually the power plants that you see are going to be thermal in nature, so they'll use natural gas or nuclear or coal or other heating, and you can get geothermal as well, but you use that energy in water and then you run it through a steam turbine, and that turbine will get the energy out of the pressure that you're creating with the temperature difference of the water by boiling it. Now, so that's energy. So energy is this defined value that's a joule in the international units. And a joule is the potential to do work, but what is work, I guess? What is the next step would be, what is power? Which power can be defined as work. And power is actually using that energy. So you have energy stored, or you have potential in the electrical system just in the form of voltage, and that is converted to do work. So when you plug in a pump or a heater into the wall, in the case of the pump, you're doing work. You're actually transporting fluid or pressurizing that fluid, and you're doing that using the potential in the electrical grid, right? In the form of a heater, you're converting that heat and warming an object, right? And so that's the potential that we have having energy all around us, is we can purchase different systems, and those systems can be created so that they can convert power in the wall, the electrical power, and do work for us. So you can have it filtering air in your home, or your blower on your furnace, or doing all the things that we like to do. So that is converting energy into something useful and doing actual work. So doing something, conveying something, breaking things up in the form of construction. You can break things down, transport them, and utilize them in construction to build buildings and things. So today we went over what energy is and kind of defined what energy is, and also what power is. And so for us, as we're learning, we don't have to go too deep usually to learn these things, but it's good just to get a cursory knowledge of everything and how it's working, especially in the form of energy, because when we're on our journey to become energy resilient, we want to know what different systems we can get to get energy to give us the resilience or the energy independence that we want. In the form of people that live off-grid, it can be nice if you're looking at properties to find something that may be able to give you energy. So there could be a small river in the area, there could be wind in a certain area on your property where you could have a wind turbine. Having access to solar all year round can be very helpful. I've been on some projects, so being able to have solar interact with your home or your cabin that you're building all year round is very valuable. I've been on some projects that are off-grid where the home is nested in the mountains, and so when the sun gets lower on the horizon during the winter, they get very little sun and sometimes no sun for a few weeks, just because of the angle of the sun. So in that case, that's where you have to bring in some sort of chemical energy storage usually. So you'll have propane or diesel or gasoline to run generators during the time when the sun's not available. Usually in the winter, having a combination of wind and solar can be optimum, just because you will usually have more wind during the stormy season, the winter season, and also in summer as well. So when there are clouds, you can harvest energy from the wind, and that can kind of fill some of the gaps. But in truly resilient systems, it's usually required that you have some sort of chemical energy system, just because the wind can fail you very easily, and solar is consistent, but it also has down times where the sun doesn't come out due to storms for 3 to 7 days. And to build a system, an energy storage system that will span that gap in energy would be very large, or you'd have to reduce your requirements for energy to be low enough that you can last that long. So those are kind of the options in a cabin setting. For RV settings, there's different levels. So anytime you're doing an energy storage system, you need to figure out how much energy you need, what creature comforts you would like to function. So in an RV, usually people don't need air conditioning because they're transporting the RV somewhere nice in the summer into the mountain, high in elevation, to have an area, to be in an area that's cooler, so that usually can accommodate you. But if you are a boondocker in the middle of the humid desert and you stay a little bit too far into summer, then that could be a time when you do need air conditioning to cool your RV throughout the day. So now that we know what energy and power are, we can start to get into more of the detailed information of what you need to know to build your system for whatever scale you want. So in an RV, air conditioning, you're going to be looking at 10 to 15 kilowatt hours of storage minimum to run the air conditioning. If you're just running water pumps and the furnace and just the blower on the furnace and a normal lighting and microwave and maybe a hot plate, then that's going to be more in the range of 2 to 6 kilowatt hours. But it's really dependent on what you need and how you want your system to work and how resilient you need it to be. It's the same once you go down to the small power units, so you can get a 500 watt hour power unit that can run a small slow cooker, or it can run a laptops and communication devices for a couple days. And as you're researching and trying to figure out what you want kind of in the form of creature comforts in the event of a power outage, we can start to use power meters and things to help you figure out how much power that needs, and then we can calculate the losses and how long you want it to run, and that will give us the total system size. So this is kind of the basics of what everyone has to do when they're building a system, an energy storage system. Energy storage systems are much more frequently in the news now because we're moving away from kind of the base load generation, which would be coal-fired power plants and natural gas and kind of all these base load systems. So as we go away from those, we need energy storage to fill the gaps from the wind and solar options. Nuclear is an amazing option for large-scale energy, but we'll dedicate a whole show to teaching you more about the large generation facilities and kind of the ins and outs, how long it takes to spin them up and what their efficiencies are. And you guys can decide what you guys think about those systems. So I think that's everything for today. So we learned about energy and power and systems on different levels. The first step for you guys as you're on your journey to become energy resilient would be to start characterizing how much power you use and how much energy you use. Thank you. Please like and subscribe. We'll talk to you later. Have a wonderful day. See ya.